We're on problem 70, and they still want us to do some sequences in series. What is the nth term in the arithmetic series below? Which means that it just increases by a constant amount every term. So let's think about it a little bit. The first term, right? The first term is 3, and then we increment it by 4 each time. Let me write all of this. 3, and then we go to 7, then we go to 11, and then we go to 15, then we go to 19, right? So we go 3, and we're adding 4 every time. Adding 4 every time. Right? So you get the sense that each term in the sequence is going to be 4 times the nth term, right? But that doesn't quite work out, because I've had 4 times, if this is the first term, 4 times the first term is 1, and 3 is less than 1. And then 4 times 2 is 8, and 7 is less than 8. And 4 times 3 is 12. But this is 1 less than 12, right? So it seems like all of these are 1 less than a multiple of 4. So the nth term is going to be 4n minus 1. And that should work out, right? The third term is 4 times 3, 12 minus 1 is 11. And that's the third term. So that's 4n minus 1, which is choice D. D. Next problem. Problem 71. Let me copy and paste it. I'll copy and paste all of them. All right, which expression represents f of g of x if f of x is equal to x squared minus 1 and g of x is equal to x plus 3? So a lot of times these seem daunting, but when you get used to it, these kind of become kind of fun problems. So f of g of x means in f of x, everywhere where you see an x, you have to replace it with g of x. So f of g of x is equal to g of x squared minus 1, right? No, all I did is if I said f of dog, wherever I see an x, I would replace. So f of dog would be dog squared minus 1. Whatever I see an x, I just replace it with whatever I input in right there. So they want to know f of g of x, I stick a g of x there. So it's going to be g of x squared minus 1. Well, what's g of x? Well, g of x is x plus 3. So this is going to be equal to x plus 3 squared minus 1, which is equal to x squared, plus 6x plus 9 minus 1, which is equal to x squared plus 6x plus 8, which is choice B. B. Next question. Given that f of x is equal to 3x squared minus 4 and g of x is equal to 2x minus 6, what is g of f of 2? Well, here, since they gave us an actual number, so they didn't leave it abstract, we could figure out what f of 2 is and then put it in and then pop it into g. So what's f of 2? I don't know if you can read. Yeah, you should be able to see that color. F of 2. Wherever you see an x, you replace it with a 2. So that equals 3 times 2 squared minus 4, which is equal to 3 times 2 squared. 2 squared is 4 times 3 is 12 minus 4 is equal to 8. So f of 2 is equal to 8. F of 2 is equal to 8. So g of f of 2 is equal to g of 8. Right? And what's g of 8? G of 8, everywhere you see an x, just pop in an 8, is equal to 2 times 8 minus 6 is equal to 16 minus 6, which is equal to 10. Choice D. Problem 73. If f of x is equal to x squared plus 2x plus 1, and g of x is equal to 3 times x plus 1 squared, which is the equivalent form of f of x plus g of x? So essentially, they just want us to add these two functions, right? So if we say f of x plus g of x, let me do that. F of x, and I'll do it in another color, plus g of x. Well, now we just add them. What's f of x? F of x is x squared. I'll do it down here. X squared plus 2x plus 1. That's f of x. And then we're going to add g of x to that. Plus, oh, I see why it's a little, they want us, g of x, you kind of have to expand this out. So g of x is 3 times x plus 1 squared. Well, that's 3 times x squared plus 2x plus 1. But then from here, we just have to simplify this all out. And I'll do that in a third neutral color. No, cancel. Do this in brown color. X squared plus 2x plus 1 plus, distribute the 3, 3x squared plus 6x plus 3. And now let's see, you have an x squared and a 3x squared. You add those together, you get 4x squared. And then I have a 2x and I have a 6x. Add those together, I get plus 8x. And then I have a 1 and I have a 3. So plus 4. 4x squared plus 8x plus 4. And that's choice C. Next problem. Next page. All right, let me see. What do they want us to do here? A math teacher is randomly distributing 15 rulers with centimeter labels and 10 rulers without centimeter labels. All right? What is the probability that the first ruler she hands out will have centimeter labels and the second ruler will not have centimeter labels? So, okay, let's think about the first one. I'll do that and I'll color code it. So what is the probability that the first ruler she hands out will have centimeter labels? First ruler she hands out will have centimeter labels, right? So there's a total of 25 total rulers, right? 15 with centimeters and 10 without. At least initially, there's a total of 25 rulers. And they want to know that the first ruler she hands out will have centimeter labels. So 15 have centimeters. So the probability is 15 over 25. That's the probability of the first one having centimeter labels. Probability of first with labels. That's that one. Okay. But they want to know the first one having centimeter labels and the second ruler not having. And you can't see that highlight color. And the second ruler will not have it. So this is, so you're going to have to multiply the probability of the first ruler times the probability that the second, without labels, so without labels. And now this is the key. Given that the first ruler had labels. Given that first ruler with labels. Now this might all seem really complicated with the notation, but when you think of it intuitively, it should hopefully make some sense. I've given away, so the first ruler, there was a 15 out of 25 chance that I've given a ruler with labels. Now in the second ruler, since both of these things have to happen, I can assume that I've already given away the first ruler having labels, right? So how many rulers do I have now? Well, I definitely have 24 rulers left. And now, how many of these do not have labels? Well, the first ruler I gave away had a label. So I still have 10 rulers that do not have a label, right? If you wanted to ask the opposite question, or a similar question, you said, what is the probability that the first two ones that I hand out have labels? It would be 15 over 25 times 14 over 24. But because the labels would have been decremented after the first one, because we're assuming we have to say both of these things happen. Now we're saying, okay, we're going to have one less ruler, but I haven't reduced the number of rulers without labels. But anyway, let's just simplify this out. This becomes 15 times 10 divided by 25 times 24. We can do a lot of canceling, so we don't have to multiply. So you divide that by 3, you get 3. Divide that by 3, you get 5. Divide that by 5, you get 1. Divide that by 5, you get 2. 3 times 2 is 6. So this is equal to 6 over 24, which is equal to 1/4, which is choice A. Choice A. Next problem. Let's see. Problem 75. On a certain day, the chance of rain is 80% in San Francisco and 30% in Sydney. Fair enough. Assume that the chance of rain in the two cities is independent. What is the probability that it will not rain in either city? Okay, so it's going to be the probability of not rain, not in San Francisco, times the probability of not in Sydney. Right? Because we have to have both of these things happening and they're independent. So the probabilities will be multiplying. So what's the probability of not having rain in San Francisco? They gave us the chance of having rain as 80%. So the probability of not having rain is 20%, or I like to stick to the fractions. 20% is 1/5, right? There's a 1/5 probability of not having rain. What's the probability of not having rain in Sydney? It's 30%. Actually, I probably should have stayed in decimal world. So let's see. It's 20% in San Francisco, 20% in San Francisco of not having rain. And the probability of Sydney of not having rain is 1 minus 30%, or 0.7%, or 0.7, which is 70% of chance of not having rain. And that is equal to 2 times 7 is 14. We have two numbers behind the decimal point. So there's a 14% chance that it will not rain in either city. And that is choice B. That is choice B. Next problem. Oh, actually, I'm out of time. See you in the next video.